Hello friends, welcome to Joy of Life. So today we are again going to see a medium level problem from Leetcode. The problem number is 64. The problem name is minimum path sum. So let's look at the description. Given a m into n grid filled with non-negative numbers, find the path from top left to bottom right, which minimizes the sum of all numbers along its path. And it says in a note that you can only move either down or right at any point. So this is our starting position, and we are going to go here. And there could be several paths. So either we can move down or we can move right. So there could be a path like this. 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 So we need to figure out what is the path that cost us the less. So if we take this path, say this path, so it cost us 1 plus 1 2 plus 4 6 to 8, and it cost me 9. Whereas this path would cost me 1 3 4 1 5 6 7. This would cost me 7. So we need to figure out the shortest or the minimum path where the sum would be the least. So that is what we need to find. So let's look at example number 2, and here they have given something like, if I create it over here, so it would be something like 1 2 3 and 4 5 6. So we need to reach. So one way we can go is uh, like this. We can go and reach here. Would cost me 16. One way could be reaching like this, which would cost me 6, 5, 11, 12, 13, which would cost me 14. One way to reach could be this, which would cost me 9 and 3, 12. So we can see this being the cheapest of all. So our answer is also 12 over here. So we will see the solution, but as I always recommend that before you look at the solution, do give it a try yourself and try to see if you can solve this problem, or at least come up with the approach, and then you can resume the video and watch the solution that I have in mind. Okay, so this is basically a very simple level dynamic programming problem. So having said that, as I always say, the dynamic programming, what it does is it solves all the sub problems along its way. So at every stage, so let me get the input data from the example, and we'll walk through it. So here we have our input matrix over here. So we are going to come up with a table which we'll call it as a DP table, or whatever table you might call it. It's not necessary that you have to call it DP. And the DP table would be of the same size as our input table. So here I have created the table, and uh, we will be filling up this table based on the inputs given on the input matrix. So what happens when we fill up this cell over here? So this cell signifies what if the matrix is of size 1 into 1. So this is my starting position, this is my ending position. Similarly, this cell signifies that what if I have a matrix of size 3 by 2. This signifies 2 by 3, and all the way till here we'll have our answer where we have the actual cell that we are answer that we are looking for. So each cell will have its own answer. So this cell will tell me, this cell over here, it will tell me what is the minimum cost of reaching this cell. This cell will tell me what is the minimum cost of reaching this cell. This cell will similarly tell, all the cells over here will tell you what is the minimum cost of reaching that cell. So let us create the table once more, and let's fill it up. So say when I am at the cell 0, 0, that means my source and destination is at the same place, and do consider this as my input matrix. So if so I am at row 0 and column 0 at the moment. So if my source is row 0 and my destination is also column 0, what would be the minimum cost? The minimum cost could be the value that is present on that cell, nothing else, right? Similarly, if I have to go to the row 0, column 1, that means this cell over here, 0, 1. So to reach this, the only movement that I was allowed is a right movement. So the cost of reaching would be the cost of my previous cell, the cost of this cell plus the cost of this cell. So it would be 4. Similarly, to reach this cell, it would be the cost of all these 3 cells, this, and this, right? So it would be 5. So basically, we are filling up our base cases over here. So when my row is 0 and when my row or column is 0, row equals to 0 or column equals to 0, that's when we are filling up our base cases. Okay, and similarly, when we are filling over here the columns, when we are filling up the column, we'll do the same thing. The cost of reaching this would be 2. So 1 from here and 1 from this cell. So 1 plus 1 is 2. Similarly, this cell would be 6. So 4 plus 1 plus 1. Okay. Now filling up the rest of the cell will have various options for me. So say when I am calculating for this cell, so when I am calculating for this cell, I have two options to choose from. Either I could come like this or I could come like this, right? I have two choices to make the choice from. So what happens is, so let's call this, so we are calling this dp, right? So when I'm filling up for dpij, so our input say is we call it as input only. So we have to take the value from input ij because that is the cost that I have to bear, which is 5, because I am stepping on that cell. So this remains at 5, right? And we have a choice to make now. So since I can come here from two directions, right? Either I could come from the left or I could come down from the top. So I am going to choose the minimum. Choose the minimum between the cell that is on my top. So here, if you noticed, we have already answered what is the cost of reaching here. And here also we have already answered what is the minimum cost of reaching here. So I will take the minimum between 2 and 4. So basically what am I checking over here? So I am basically checking that dpi minus 1. dpi minus 1 means we are just going a row above and staying at the same column, dpi minus 1 and j. So this is my first choice, and my second choice is, so I move up, that is this one. So just I'm doing a I minus 1, but in the other case, the other choice would be I and j minus 1. So I remain at that same column, but I am going one step left. So I am taking the minimum of these two values, right? So 5 plus min between dpi minus 1j, that is 4, and 2. So of course minimum is 2. I'll take 2 and my answer for this row would be 7. So if you notice that this is the minimum cost that I have to bear if I have to reach here, and that is through this route. This is the route that I am taking to reach that cell. 5 plus 1 plus 1. Okay, similarly when I'm filling for this cell, again I have two choices. I can come from right or I can come from top. And the cost of this cell is 1, and I choose using this formula that I have stated over here. I am choosing the smaller of the two. The smaller of the two is 5. 5. So the value that I get over here is 6. And how we are getting that 6? 1, 3, 1, 1. 1 plus 1, 2, 2 plus 5, 2 plus 3, 5, 5 plus 1, 6. So this is the value we are getting over here. Again, when I'm filling up for this cell, I have two choices, either come from here or from here. and the cell value that we see is 2. So 2 plus minimum of 7 and 6. So of course 6 is the smallest, so 6 plus 2 we get a value of 8, right? And how do you get this 8? 1 plus 1 2, 2 plus 4 6, 6 to 8. So this is the minimum cost reaching to this cell. Now getting the value for the cell that we are looking for. So currently the number is 1 and we have two choices, that is 6 or 8, and we take 6. So 6 plus 1 is 7, and this becomes our answer. So the minimum cost for reaching this cell is 7, and we'll just verify it with over here, and we see that the value is nothing but 7. Similarly, for 1 2 4 5 6, if we just go over it quickly, so say 1 2 3 4 5 6. So this is my input, and say this is my DP. So we know for first cell it is 1, the second cell it will be 2 plus 1, that is 3, and this one will be 3 plus 2 plus 1, that is 6, and this one would be 4 plus 1 5. So now filling up for these two cells that we have, so to reach this cell it would be the cost of that cell 5, and we have a choice between 3 and 5, and we choose 3. So 5 plus 3 it would be 8. So we get the value 8 over here. Okay, and for the next cell, the cost of this cell itself is 6, and we have two choices, 8 and 6. So we choose the smaller one, which is 6, so we get a 12 over here. And this is my answer to the problem. So let's just quickly look that is it correct or not. So we can see that, yeah, this is the answer that we are looking for. So yeah, this is a very basic level dynamic programming problem. There could be other way of solving as well, but I thought of making it on the dynamic programming part itself. So let's go into the solution. So what I do first is create the DP table, and since it's a m into n, so I'll do a grid dot length and grid 0 dot length. So again, it is not about the pattern, but I wanted you to understand what is the essence of why we are looking at such a pattern. So I think this problem is pretty simple, and you might have got already what I am trying over here. Okay, so for first base case is the zeroth row, zeroth column. It is nothing but we copy the value from the grid itself. So we just blindly copy the value from the grid. We do nothing, and then we start iterating over the grid array. So again, I am not going to speak through this iteration part, but you know what I am doing over here. Caps lock. Okay, so we are just traversing the array. It's a regular array traversal logic that I'm writing over here. Okay, so now the thing is that we are not, since we have already processed for the 0 and 0 row and 0 column, so I would remove that. So if I equals to 0 and j equals to 0, then we don't need to do anything because we have already filled it up, right? Now we have talked about two of the cases for when the row is 0 and when the column is 0. So those two cases also we need to handle. So we'll just put a else if over here, else if I equals to 0, say. So in that case, what I'll do is we are just going to look at our previous value and add the value, value from the current cell. So we will just go and check the value from the previous cell. Sorry, it would be I, right? So we'll just look up the j minus 1 and we will get the value from the grid. Okay. And similarly for j equals to 0 also, we are going to do the very same thing. So we are going to just have the same thing, but instead of changing the column, I'll just change the row. Yeah, that is it mostly. Okay, and for everything else, so what everything else means, this part that I am marking over here. So for this part, for any size array, if you remove the row and the column, for let's say if I have a bigger dimensional matrix, so again these become my base case, right? This is where I equals to 0 and j equals to 0. Either of these will cover this part. And for the remaining part, whatever is remaining, that is this part, we always have a choice. Either we can come from right or we can come down from the top. It is valid for any of the cell. So that is being covered in the else part. So what I'm going to do is we are going to put into dpij, and we are going to get the value from the grid, that is the grid's value, and then we are going to get the minimum from the two choices that we have. One is on the top, the one is at the right. So it's I minus 1j, or dp I j minus 1. So these are the two cells that we are going to get the minimum from. And as we are done processing, we know our answer would be ready at in the DP table at the last row, last column, right? So we can just say, since they are of the same length, so we can say grid length minus 1 and grid 0 dot length minus 1, because they might be of different size, right? So it could be either of the one. So this is a very straightforward solution. So let's run and check. So you can see that it has been accepted. So let's submit and check for a broader range of test cases. So yeah, it has been accepted with which is faster than 83.71% of the submission, which is not bad. And the memory usage is also pretty much the same. So we are using O of mn space, the mn being the row and column of the grid. So the complexity is also order of mn. So I think this will give you a very clear idea on on how to approach this problem and how to solve it. Hope you like the video. I'll create some more problems, some more difficult one rather, for dynamic programming, which will give you some more insights on how to solve dynamic programming problems. So thank you once again. To share a like, and it would highly motivate me to create more. As I am going towards 100 subscribers, it really feels great to get your support and love for the channel. Thank you once again and have a great day. See you again. Bye bye.